In the last video, we reviewed how to multiply out trig expressions. Now we're going to just undo that, and undoing multiplication is called factoring. So if I have this, cosine squared theta minus sine squared theta, remember what that means. That's cosine of theta, quantity squared, minus sine of theta, quantity squared. That's a difference of two squares. What's nice about that is that always factors. What I'm going to do is I'm going to get the sum of the two things that I was squaring, so that would be cosine theta plus sine theta, multiplied by the difference of the two things I was squaring, cosine theta minus sine theta. The generic version of this is that a squared minus b squared factors as a plus b times a minus b. The reason that works is because if we were multiplying this out, we would have to FOIL it. Well, the first terms, that's going to give me my cosine of theta squared. The outsides and insides are going to be exact opposites of each other. So they're still there, but they cancel each other out. And then the last terms give me my minus sine squared. Okay, if I have this expression, this has 1, 2, 3 terms, so we call that a trinomial. I'm going to hope that that's the result of foiling, and I'm going to try to unfoil it. Although when I unfoil, I actually really unfloy. Because the oi, the outsides and the insides, which form that middle term, that's the most complicated piece. So this is just strategic procrastination. Do the simpler parts first. Okay. So if my first terms are going to multiply to give me 2 copies of sine squared x, I'm thinking I'm going to need to have a 2 sine x and a sine x. That way that product would be 2 sine squared. Okay. I'm hoping that this factors with integer coefficients. I'm not going to try anything fancy like 4 times a half. I'm just going to hope that 2 and 1 will work. Okay. Now the last terms have to multiply to give me 1. Well, that's lovely because there aren't a whole lot of pairs of integers that multiply to give me 1. Would have to be 1 and 1. And because I want to get a negative, I can see that they've got to be opposite signs. So I'm going to have 1 positive 1 and 1 negative 1, and I just have to figure out where they go. That's where the oi is going to come in. Whatever I put here is getting multiplied by 2 sine x. Whatever I put here gets multiplied by sine x. I need those guys to combine to give me a negative sine x, which means I want the 2 sine x. I want the bigger one to be negative. So I'm going to put a negative 1 here and a positive 1 here. Quick check. 2 sine squared. Outsides are negative 2 sine x. Insides are plus sine x. That gives me a negative sine x. And last terms are a negative 1. Okay, so that worked. Okay. Now, as we're doing the factoring, that's often something that students struggle with. It's a skill you've seen before, but it's something you may have struggled with in previous classes. Others of you are like, factoring's easy, no problem. If you feel like you're struggling with the factoring, it is covered in the review section. You might want to just flip back through that, or if you've got notes from a previous class, and look over those. I'm also very happy to practice factoring in office hours. So if you feel like you need some additional practice, never be hesitant to ask. If you feel like, hey, I'm weak in this area, but I want to get better, I'm going to hear that I want to get better. That's what I like to hear as a teacher. It's fine if you're starting out weak in something. If you're motivated to improve so that you can get to the point where you can master that skill, I want to help you get there. So don't hesitate to ask. I'm going to have you practice one of them. This is one from the homework. There are 2 parts to it. There's 17a and 17b. 17a is a squared plus 2ab plus b squared. And 17b is cosine squared x plus 2 cosine x cosecant x plus cosecant squared x. Essentially, these are the same problem. Here, instead of having an a, I have a cosine of x. And instead of having a b, I have a cosecant of x. This is something some of you may find helpful. If it feels intimidating having these trig functions here, you could do a substitution. You could say, let's let cosine of x equal a. Let's let cosecant of x equal b. And then you could rewrite it this way, do the factoring, and then substitute back in. If you're comfortable factoring it just as the trig function, that's totally fine. But go ahead and work this out. My goal is to have you get 17b done. If you find it helpful to use 17a first, totally fine. If you feel comfortable going right to 17b, that's also totally fine. Okay? So try that, and I'll see you in a moment. I'm going to try going right to 17b. I'll go ahead and write out the answer to 17a once we've done that. But let's try going right to this. Notice I've got 3 terms, so I'm hoping that this is the result of foiling. This is a little bit more complicated than the last example we did, though, because that's not just a number. Instead of having a number, I've got some cosecants squared. That's okay. If my first terms are going to give me cosine squared, I'm thinking it's got to be a cosine and a cosine. So I'm going to put a cosine x and a cosine x. Now, instead of looking for just numbers, I basically have one copy of cosecant squared x. Okay, so I'm looking for numbers that will multiply to give me 1. Those will be my coefficients. And I'm kind of thinking I want to have a cosecant and a cosecant. Okay, so I can, the integer coefficients that would multiply to give me 1 would be 1 and 1. They've got to be the same sign to make this positive. And then they could both be positive or they could both be negative. But if they were negative, that would make my outsides and my insides negative. And I want to end up with a positive. So I'm thinking just one copy of cosecant x in both places. Let's see. Cosine squared. Outsides are cosine times cosecant. Insides are cosine times cosecant. That gives me 2 copies of cosine times cosecant. And then last terms, cosecant squared. Excellent. If you found it helpful to sort of do this substitution and factor this, which looks a little bit simpler, it would have been just a plus b times a plus b. Okay. Again, I feel like doing this is optional. If it helps you to get this, fine. If you were comfortable getting straight to here, I'm fine with that too.